Okay, cool. So standard form, we're going to have some sort of coefficient, and then we'll have a variable, and then we'll have an exponent, right? If it's in standard form, these exponents need to be going down by number. So if it's in standard form, and this is a 5, 4, 3, 2, 1, you're not going to see a 1, and then a 4, and then a 3, and then a 12. It needs to be in decreasing order. So plus c, x to the n minus 2, plus da, da, da. So an example of that would be 5x to the 6th plus 2x to the 3rd minus 10x squared, or something. And what I really care about is this number, wait for it, hold on. That number, and that number. I don't care about the 5, I don't care about the 2, I don't care about the negative 10, I care about the exponents. So we can classify these polynomials two different ways. We can classify it by its degree. So in this case it would be a 6. Or we can classify it by the number of terms it has. So this one right here has 3 terms. There's 3 different pieces to it. If it has a 0 degree, so it's just a number, I'm going to call it a constant. 12, 17, 32, there's no variable. It's just a number, I'm going to call it a constant. If it's linear, that means it's x to the first power. So maybe like x minus 5. Apparently we like 5. Say 5. If it's a quadratic, the exponent has to be to the second power. Now, it doesn't matter how many terms there are, and it doesn't matter if that power comes first or not. I'm still going to call it a quadratic. Now, is that quadratic in standard form? No, right? But it's still a quadratic. A cubic, x to the third power, something like that. It doesn't matter how many terms there are. A quartic, yes, this is where we ended last year. You should have learned constant, linear, quadratic, maybe cubic. We're adding 2 more, quartic, like quarters. Something like that. And quintic would be to the 5th power. 5. It has to have a 5th power to be a quintic. You won't see anything above that, or you shouldn't, at least, in this class. Nope, so this one's not. Oh. All right, now we're going to number it by the number of terms. If there's one term, so say like 7x to the 5th, it doesn't have anything to do with the 7, it doesn't have anything to do with the 5. It has to do with the fact that there's only one term here. It's called a, do you remember? Monomial. 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 If there's 2 terms, so 5 minus x, it would be called a binomial. Okay, like a bicycle. Three terms, trinomial. So on your own, name one. Put a trinomial on there. If I weren't recording, I'd get after you for that. Taking notes. Yeah. Okay. Yeah. That means the 3x and the x need to be combined to the 2x plus 7, and I'm going to call it a binomial. Yeah.
So we're going to put it in the binomial right there. What does that do in minus?
This one right here?
Yeah.
The 5 and the x don't combine. So 5 minus x.
Yeah. So they don't have to be.
Nope, it can be a constant because the constant is considered a term. Yeah. Okay. Hey Nate, will you shut my door for me? Thanks. Okay, so this one, recap really quick. This one is a monomial because it has one term, right? The next one is a binomial because it has two terms. The next one is a trinomial because it has three terms, and so on. So if I wanted to name a polynomial of 4 terms, I would just have to make sure that there were 4 pieces to it, right? With pluses or minuses in between. And if I wanted it to be 5 terms, this really is just me being lazy and not wanting to write it. I just have to make sure there were 5 pieces, right? Okay, moving on. That's pretty though, yeah? So for this first one, I want you to write it in standard form. I want you to classify it by its degree and by its number of terms. And while you're doing that, I'm going to hand something out to you. Either this is either going to be extra work for you or it's going to be drilling. And something for the drilling part. I'm going to do this maybe. One of it. That might be something. You let me know if you have extra. You. This is everything that I think you should know this unit. So we already did 2.2. Remember how we did the exit flips last year and you just kind of decided if you got it or if you didn't? At the end of today, I want you to just check mark. Did I get it or did I not get it? Now if you check mark, and nobody's going to see this besides me and I won't see it until the end of the unit. But if you check mark on 2.1 that you don't understand how to classify them, you just say, nope, I don't get it. You need more? As you work throughout the course of the unit, you can kind of keep check marking it up. So if I put notes today, but then I study, I do my homework, next time I get a little bit more help and I almost got it, like you can keep kind of checking it up until you're all the way to the got it part. The whole point is, I'm hoping that between now and the test day, you'll either got it or you kind of got it for everything, right? This is a way for you to kind of keep yourself organized. Do I know how I need to when the test is coming? I'm good and closer to done on test day. So it is an assignment. And if it's helpful, we'll continue to do it. If it's not helpful, then we'll scrap it. I don't want to try it. So the first one today, classify polynomials. So I can for all of these things. I can classify polynomials by degree, number of terms. So let's do it together. Let's see if you can do it and if you feel good about it. So the first one, if I wanted it in standard form, this guy right here has to be my leading coefficient, right? How come? It has the highest power. So 5x to the 4th. What would come next? 3x cubed minus x. That's how you write something in standard form. Part B, I know that there's more, but part B, what's the leading term? Negative 4x to the 5th. We take that minus with it. Then what? Plus 2x squared. Now this kind of goes with what Wagner just said. What do I do with that 3 and that 10? Plus 13. Before I can classify them, I have to make sure all of my like terms are combined, right? So let's go back to part A. Name it by degree. The degree is a 4, right? Right? So it's a quartic. You already said that. And how many terms are there? 3, so it is a. If you don't have that memorized by September 25th-ish, you won't have it for the test. So you have to, between now and then, memorize these terms. Part B. Leading coefficient, or its degree is a 5, so it's a quintic. There are 3 terms, so it is, again, a trinomial. Now the degree of the polynomial, so the 5, the 4, the degree of the polynomial affects the shape of the graph. and it determines the maximum number of turning points. By turning points, I mean the places where the graph changes direction. And then we're just going to pretend that this is not here. That not here. So, because the degree affects the way the graph looks, just watch for a minute. If you want to get out a piece of paper, you can. I don't care. If you want to just watch, you can as well. Hold on. Fantastic. Okay, so we're just going to kind of explore and see what different types of graphs look like. And then we're going to make some rules. If I have anything x to the first, by the way, x to the first is classified as a what? Linear, right? First is linear, which means it looks like a line. That's something that is on the secondary 1 core. We won't really be doing very many lines this year, or any. Okay? We'll be doing logarithms, but not lines. Okay, x squared. That's what we studied last year in secondary 2. What does it look like? It's a parabola. X cubed is one of the functions we will learn this year. It looks like this. Now there's two things that could happen. It could kind of just like snake up like that, or it could go up, down, and back up again. Now on this one, how many times does that turn? It does. This one right here, it never turns. It just always goes up. So if I'm talking turning points for this one, TP turning point, it could possibly not turn at all, or it could turn here and here, right? So it could not turn at all, or it could have 3 turning points. Go back to this one. How many turning points are there? 1, always. No, it only like this one. So, no, turn here, turn here. So I'm not talking like intervals, like I'm not talking this, and then this, and then this. I'm saying I turn right here, I turn right here. That's where my graph turns direction. Let's look at x to the 4th. X to the 4th could look like this, or it could go down, and up. Yep. X to the 5th could kind of snake its way up. It could go up, or like that. X to the 6th, this is the last one we'll do. It could just be nice and smooth. It could look like a W. Or it could look like a... I don't know. I was thinking something else. Okay, talk about turning points here. X to the 4th could have 1, or it could have 3. Let's write that out. 1 or 3. What about x to the 5th? It could have 0, right? Or 2, or... My point with doing this is I want you to recognize the pattern, and we'll get there in just a second. X to the 6 could turn, let's start here. It could turn 5 times, it could turn 3 times, and it could turn 1 time. Let's write that out. 2, 0, 2, or 4. Okay. So let's come up with kind of a rule. First of all, what do you notice about the turning point? Okay, my odds, we notice a couple things. The maximum number of turning points has to do with what in relation to the degree? The maximum number of turning points with relation to the degree is what? 1 less. So my first rule is the maximum number of turning points is always 1 less than the degree. And I think that shows up right here. The maximum number of turning points is determined by n minus 1. Right? So that being said, if there is an odd degree, then there has to be an even number of turning points. And if the degree is even, then there has to be an odd number of turning points. Now, the other thing, what else do you notice? Between the 4, the 2, and the 0. Between the 2 and the 0. Between the 5, the 3, and the 1. What do you notice? It always goes down by 2. And without getting too much into it, the reason it goes down by 2 is because of imaginary solutions. Now, last year when we did quadratic, some of our answers were imaginary, right? Now, by imaginary, again, I don't mean to make believe, but that's the kind of answers there are. If I'm dealing with an x to the 4th degree, and there's only one turning point, that means in here I've got 2 imaginary solutions, which we will find very soon. Not today, though. Okay, cool. The other thing I want to talk about on this is the direction that my arrows are going. I think that's next, but let's look back at your notes really quick. Okay, so the degree affects the shape, determines the maximum number of turning points. Okay, cool. So let's try these examples. If this is my polynomial, I want to find the maximum number of turning points and everything that's possible. So the first thing you want to do is, what's the leading term? If I were to write it in standard form, 5x to the 4th. So this would be my leading term. My degree is 4, so the maximum number is 3, one less. But the possible numbers could be 3, but it also could be, goes down. 1, yeah, otherwise we'd never end, right? And again, it depends on what kind of solutions there are. Always goes down by, oh yeah, the maximum is down by 1. What about this one? The leading term would be what? It's negative 4x to the 5th. So the maximum is 4, is 1 less. The possible would be 4, down by 2, down by 2. Sydney, sorry. Nope, not at all. It's just the leading one. Because x to the 4th, so say I plug in a 2, or 5, let's plug in a 5, so it's x to the 4th, x cubed, x squared. If I plug in a 5 here, that's like 625. That number is affected a whole lot more than if I were to plug in a 5 here, 25. Like the 4th power has a lot more weight to it, so that's how it's affecting the graph a lot more. Anna, what was this? Are you okay with the 4th? Yeah. It always goes down by 2. And it starts at the maximum. Yeah. Just depending on it. So it goes down from the maximum. So the maximum possible, let me give you another one. If I had, you okay? Sorry. Okay. Oh, I should remember that. Right? Okay, now let's talk about end behavior. End behavior is, yes? You always go down by 2. Well, it depends. What's your question? Ask again. Restate. Okay, hold on. If your max is 3, then your polynomial would have had like 5x to the 4th minus something, I don't care. If your maximum is 3, that means it was a 4th degree polynomial. Is that okay? So between here and here, it's always a 1. But you never go to negative. No. Because you turn to negative 1. Moving on. End behavior is the, I don't remember what we're going to put here. Let me tell you how I feel about feeling. And behavior is the direction of the graph from the far left to the far right. And then just pretend like there was a period here. Ignore that. I want to go back to the other page where we have all of the graphs to decide if we can figure this out without looking at a chart. So looking at the end behavior here, what do you notice about all of my odds? Well, let me get rid of all of these. What about all of the x's, or the odds? What do you notice? One of them goes this way, and one of them goes up, right? One goes down, one goes up, one goes down, one goes up. Is that okay? Mm-hmm. And that happens every time my power is odd. When my power is even, what's happening? They're going the same direction. That always is true. So going back to our note, if A is, okay, I like, come down here. Let's sketch these first and then we'll go back up to that one. Part A, if I have a positive even function, what I mean by that is, like maybe for an example, 3x to the 4th. It's positive. It's positive because of the 3. It's even because of the 4. Okay? Now, because it's even, that means my end behavior, they're going to be going the same direction, right? That's what we decided from the previous page. So the even means we're going to be going together. The positive means we're going to be going up. So if I were to just sketch that, they're going in the same direction and they're going up. Now, I don't know what's happening in the middle. I don't know what's happening in the middle of those two arrows. What the crazy could be going on. All I know is that they're going up together. Right here. You raise the button, shouldn't be so close to everything else. They're going up together. It could look like this. Up and then a bunch of like weird and then up again. But they're going to be going up. Now if I have a negative even function, what does the even mean again? They're going together. And the negative would mean they are going down. So if I were to just sketch it, I would sketch something like that. What's that? Yeah. This is going to help us fill out the chart above. A positive, So what's going to happen with odd? If it's positive, it means it's going to be going up, right? And odd means it's going two different ways. So we're going away from each other. Is that okay? So it's going up, and the two ends go away from each other. And again, I have no idea what's going on here in the middle, but that's what the ends are doing. Is that okay? Last one, if it's a negative odd function, what does the odd mean? It's going away. And the negative means, as time's going on, I'm going down. Now we can classify end behavior two different ways. Formally, which is a little bit more nitpicky, and informally. Let me tell you the informal really quick. Informally, I can say that these ends are going up and up. These ends right here are going down and down, right? Okay? The ends on this one are going down and up. Can you do the left side first? On this one, it's going up and down. Okay, let's do on this chart above it. So, if I have an even positive function, it would look something like this, right? So it's x. This would probably be this one. If I were to make a mistake today, this is one of the two places that I would do it. As x is getting smaller, what's y doing? Getting bigger. As x approaches negative infinity, y approaches infinity. As x is getting bigger, what's y doing? Getting bigger. And again, the informal way to write it is up and up. Formally, as x approaches negative infinity. Now notice with all four of these boxes, those look exactly the same, right? The only thing that's going to be different are these spaces right there. Everything else is identical. Unfortunately, you have to write everything else. There's a lot of writing here. Okay, let's talk about a negative even would look something like this, right? So as x is getting smaller, what's y doing? Going down. As x approaches negative infinity, y approaches negative infinity. And also notice, this down, that negative infinity, they're going to match up. As x gets bigger, what's y doing? Still getting smaller. Down and down, negative, negative. They go together. If I have a positive odd, it means it looks something like that. As x is getting smaller, what's y doing? Okay, I'm going to have you think for this one. Don't yell it out. As x is getting bigger, what's y doing? Now you can yell it out. It's getting bigger, right? So as x approaches infinity, y approaches. As x is getting bigger, y is getting bigger. Yep. Last one. If I have a negative odd, they're going away from each other, it's going down. You try to fill up those last two pieces. As x is getting smaller, what's my y doing? As x is getting bigger, what's my y doing? As x approaches negative infinity, what's y doing? As x is getting bigger, y is getting smaller. The other thing you can notice, and look at the picture of your graph. This arrow right here is pointing down, right? Well, that's a negative infinity. They're going to match up. Okay, moving on. Any questions with that section? No? All right, so for this particular problem, we want to describe the end behavior, and that's it. We want to do it formally and informally. So the very first way I would start all of these problems is we circle the leading term. You don't have to rewrite it, but you do need to notice which one's the leading term. Is it even or odd? Even. So that means my ends are going together or away. Are they going up or are they going down? Why? Yeah, positive, even. So they're going up together, which means informally I can say this is up and up. Formally, I will say as x approaches what? Negative infinity, y approaches something. Well, the first word we said was up, so what's that going to be right here? Infinity. Yeah, they go together. As x is getting, no, the y's are up, right? The x can go negative, the y's are going up. Yes? Yeah. It doesn't tell you on here, but it does on your homework. Do it both ways. As x is getting bigger, x is going this way, what's y doing? Getting bigger. So notice that between this part right here, I should be covering the entire x-axis, right? Negative infinity to positive infinity. Only thing that changes are these two.
So those two parts are going up with the letters up and down.
Yes. Do it again. The leading term for part B is what? Okay. Even or odd? Odd. Right. Odd. So there's a 5. That means, are my ends going together or are they going away from each other? Okay. Is it going up or is it going down? Going down. So, You start with the negative side first. So then the first words are exactly the same again. As x approaches what? Negative infinity. Y approaches, what else? On the left side, what are we doing? We're going up. On the right, as x approaches infinity, y approaches. On the right, what's happening? We're going down, so I think I've kind of gotten in a rut where I'm having a little math problem like the front row. Is everybody okay with that? I don't think anyone looks at the picture and doesn't know. I'm done. Try part C on your own. So where it started, I would start by circling the leading term, sketching the graph, like basic sketch. Decide if it's up and up, down and down, up and down, and out. And go from there. So an x, so this part right here is always good. And that's because it's negative, because x is getting lower. And x is going really slightly. Arrows go down. So an x approaching the negative. You can think of this as kind of like a pixel. If I were a pixel on this graph, and this was x, as x is going left, what's y doing? So again, think of it like a little pixel along the graph. As x is going right, what's y doing? It's going up. Okay, so as x is going left, the arrow going down, right? Infinity is good, x goes right. That's even, right? Which means all even ones go together, either up together or down together. Sorry, let me kind of check on half the class. How y'all doing over here? Okay, so this one, what's my leading term? Negative 14x to the 6, right? Which means it's an even power. So, does it go up together or down together? Down. If I were to sketch it, something like that, down together. Informally. Okay, so as my x is getting smaller, as my x is moving to the left, which way does my arrow point? That means y is going down. As x is getting positive, which way is y going? As x is getting bigger, my y is pointing which way? Down again. Raise your hand if you got that. Okay, let's do one more really quick. But before we can do part B, what do we have to do first? Combine my terms. So this right here, combined with this one right here, will be my leading term. And once I add those, I get x to the fifth. So the first thing, it's an odd power, which means the ends go what? Opposite. Now it's positive, right? So it would look something like this. On the left-hand side, the arrow's going down. On the right-hand side, the arrow is going up. Now how do I write that formally? As my x is going negative, my y is also going negative, right? As my x is going left, my y is going down. As my x is going right, my y is going, as x is going right, my y is going up. You good with that one? You okay? Okay, moving on. Moving on. Is this the last page? Hallelujah, right? Okay, so we're going to put it all together. This time I'm going to look at the graph, and we're going to add one thing to it. Okay, first of all, part A, what kind of, is it even or odd? It's even. How do you know it's even? Going together. Now, do we know if it's quadratic? Maybe, maybe not. But we do know it's even. So, end behavior. As x goes negative. Don't yell it out. What is it? As x goes negative, what is y doing? Okay. As x approaches infinity, what is y doing? Okay, so as x is going left, y is going up right here. As x is going right, y is doing what? Going up. Which means informally the end behavior is up and up. Uh-huh. Well, unless it doesn't tell you to. If it doesn't tell you which way to do it, I'm going to do it informally, right? It's much faster. Okay, last thing, and then I want you to try part B. Where does the graph turn? Right here, right? Now sometimes, look at part B. Part B's good. Look at D. Is it obvious on part D where it turns? No, so you just estimate. In a couple days, I'll show you how to use your graphing calculator so that you can tell me exactly where it turns. Today I'll be taking roll, and I'm going to ask you if you have a graphing calculator, and if you don't, you need to tell me when you're getting one. It has to be by Monday. Monday, our entire day is on the graphing calculator. Wednesday, our entire day is on the graphing calculator, so you need it. Anyway, my point is on these ones, just guess. This point right here, I would guess 1, 4. Anyway, so what I want you to do, part B, part C, do these first three, and I'll be right with you.
Is it based on math, or you just see what you're writing? Oh, do you know? Yeah. Okay, cool. Welcome to your
So on this one is a good example of kind of weird things happening in the middle, and we only care about the end. So as x is going left, what's my y doing? What's happening on the left side of the graph? Going up. On the right side of the graph, as x is getting bigger, y is also going down. So we know this one has to be an even or an odd. Is it even or odd? It's going to be odd because they're going opposite directions. Informally, we're going to say down and up. The left is, oh, start that reverse it. Just making sure you're paying attention. Okay, yeah, you're right, up and down. Okay, turning points on this one. Roughly 0, -2. And okay, I want to talk about increasing and decreasing. This is probably the hardest part of today. This is probably where you'll make mistakes. So maybe just watch for a minute and then write it down. Now, increasing and decreasing, I want to know when the graph is going up and when the graph is going down. And it all depends on the turning point. So this turning point right here is at x equals what? 4, is that all right? Now I want to give an interval when the graph is going down and an interval on when the graph is going up. This interval that I'm talking about has to do with the domain. So yes, I'm looking at what y is doing, but I'm telling you what x values is that happening in. Does that make sense? I want to know what's happening to y here, but I'm looking at what x values is the graph going up, what x values is the graph going down. So I only look at the domain, which is why I pointed out x equals 4. Is that okay? Now on this half of the domain, when x is less than 4, my graph is going down, right? I'm going to call that decreasing. I am decreasing. Now when do I start decreasing? At negative infinity, right? On the left, it's always going down. And then right here at the turning point, it stops going down. Where's that turning point? 4. And at 4, it starts going up, right? Now, when I'm doing intervals, I usually either use parentheses or I use those brackets, right? Now, if I'm talking, well, what's the difference? The parentheses is when you can never touch that number or if it doesn't include that number. I need to decide if the 4 needs a parenthesis or if it needs a bracket. But before I do that, I want to do the increasing part. This half the graph is where it's going up, right? It starts going up where? At 4. And it never stops going up, right? So 4 to infinity. I know the infinity needs a parenthesis. Now the question is 4. First question, don't write this down. If I put a bracket right here and right here, that would mean at 4, the graph is both going up and both going down. Can the graph go up and down at the same point? No, so that means that can't work. Right? Now look at what's happening right at 4. At this point right here, if I were to take the slope would be flat, right? Because that's the turning point, which means at 4, is it going down? No. Is it going up? No, so they're both going to be parentheses. And at 4, that's where it turns. The slope, the rate of change, is 0 there, because it's flat. Let's do it again right here. Where are my turning points? I have a turning point right here at x equals 0, and right here at x equals 1. On this part of the domain, what is my graph doing? Going down. And then for a very small section, it turns and it goes up. And then for the rest of the graph, it goes back down, right? That's kind of the idea. So it starts by going down. So in the decreasing section, I'm saying from negative infinity to where? To 0, because again, always domain. From negative infinity to 0, that's when my y is going down. Okay? So it's taking care of this part of the domain. Then it turns, and from 0 to where? 1. From 0 to 1, it goes up for a very short section. So now I've taken care of that part of the domain. And then at 1, it turns again, and now it's going down again. So from 1 to where? 1 to infinity. Now notice, Did we take care of all of the domains? From negative infinity to 0, and then from 0 to 1, and then 1 to infinity. Notice the entire domain is covered, right? A question earlier was, this is going down. Why is it positive infinity? What would your answer be? Because we're talking about the x numbers, right? For these x values, my y is going down. Do you see the difference? Okay, now there needs to be a little symbol right here in between those two to combine them together, and that's a little u. Yeah, I use union. Okay, let's do one more and then we'll call it a day and let you work on your homework so that you have some of it done before we leave, okay? Yeah, okay. Good question. Because my x value, like if I was, you kind of look at it as time's going on, if this was time. And if this were a pixel on the graph and you're highlighting it, yeah, as x is going left, it's going up like that, but you kind of look at as time's going on, if I were tracing that, I would be going down, right? Yeah. I hope that helps. Yeah, good. All right. Okay, last one. Let's make sure we're on the same page with turning point. Let's call this turning point what? 0.24. And let's call this one. That's fine. No, do I think it's right on 3? No, it's probably on like 3.1 or something, but it was close enough. If it's obvious that it's not at that cross point, don't do it at that cross point. That does mean tomorrow or next time when we correct your assignment, everybody could be just a little bit off depending on where you estimated those points to be. It's actually a really booger of an assignment to correct. There's like 72 points possible on this one, something like ridiculous. I was so bad for you except for I've already done it, but so I did the assignment myself. Promise I'm not a teacher that gives you a mother load of homework and then doesn't do it. I do it. How do you answer these? Okay, try all 5 of these. You haven't already. Make sure we're on the same page. I'll come over here this time. So, anytime on the left, so we have it. So we're great. If that is with that, I'll let you down there. So it's down and then. Is that okay? So right here, if you didn't have to do this one, right here, if I were talking increasing, decreasing, and my x is moving positive, what's my y doing? Going down. So right there it's decreasing, right? It turns right here. My x is still going positive. What's the y doing? Now it's going up. Like, I feel like that's okay, right? You're all right with that? But don't get that confused with this. On this one, as my x is going negative. So this time now, my x is going negative. As my x is going negative, what is my y doing? Going down. So x is going negative, y is going negative. As my x is going positive, so now make your x go positive. Now it does a bunch of things right here, right? It goes up, it goes down, but what's it doing eventually? As my x goes positive, what's my end behavior doing? Somebody say it out loud. It's going positive. Now if you want to know end behavior, all you have to do is look at this one and look at this one, right? Informally, my graph is going down, and then at the end of it, it goes up. Does that help clarify anything for some of you? Okay, is that the confusion? Kind of, yeah. All right, but now let's talk turning points and increasing, decreasing. So these are kind of an idea together, and these are kind of an idea together. It turns, we already listed them, right here. Is that all right? No. Okay, we've already listed it. Look up there. It turns right here is 1. This line right here is x equals 0, right? And then it turns again at x equals 3. Okay, and again, increasing, decreasing is always as x is getting bigger. So starting down here, is x getting smaller or bigger? Getting bigger. So it is increasing. When does it start? From negative infinity to when? Why 0 and not 24? Because it's always the x value, which was the mistake. You were very close. It's always the x value. Both of these need a what? Parentheses. At 0, what happens? It turns, starts coming down. From 0 to what? It goes down until we hit 3. And then it turns again. And it goes back up from 3 to... When does it stop going up? Never. Does that kind of help just fill in all of the gaps? Okay, awesome. Thanks for watching. Peace out. Oh, peace out.